Right, hello. What I want to say first before we show you anything here is that when it comes to renewable energy, if you're talking about vehicles and you're talking about a few other things besides, the centre of the universe could arguably be called the Netherlands. And I'm going to introduce you to something going on in the Netherlands, but it's one of a number of things and they're really earth-shattering in my opinion. So here we're going to interview the people from the Technical University of Eindhoven, not the people from the Technical University of Delft, who are also here at our show, who have a habit of winning the solar races with the single-person solar cars. But this is something, in a sense, a little closer to the real world because this vehicle takes 4 people and it has also won prizes in the category for just that. So could you just explain to us a little bit about the vehicle and what it was that you competed in?
Well, this is the vehicle we competed in the World Solar Challenge in Australia in 2015. And the thing is that this is a vehicle, a solar-powered vehicle, that can actually fit 4 persons in it. And that's what makes it unique compared to other solar cars we've seen. So we compete in the World Solar Challenge in a multiple seater class, and in that case you don't only get judged on speed, but also how many persons you're going to take with you and how practical is your car. So how easily can you get in, do you have a car radio,
They rate that.
navigation system, and actually this car also have a license plate, so we can just drive on the Dutch roads, and that's what makes it really different from all the solar cars people have seen.
Yes,
and that's what makes us unique.
Okay, let's ask a little bit of technology and then a bit more broadly. The solar panels are not the most efficient in the world, but they're what you could afford, and that was single crystal silicon, is that correct?
That's correct, yes.
And you can say the supplier, can you?
They're just from SunPower, so they're really high efficiency cells.
Yes.
But they're just still normal silicon, which you can also find on their homes.
Yes.
But they're the most efficient in their class, so they're about 23.5%.
So although this vehicle does not have the, so to speak, the best solar cells, which might be gallium arsenide, germanium multi-layer for 40 layers or something that goes on a satellite, or even just gallium arsenide that would go on some of the more expensive solar racers, you actually shocked people by saying that this vehicle can not only do the average commute with 4 people in Eindhoven, it can donate electricity. It's energy positive. Is that true?
That's right, indeed. We did the calculations, and even in the worst month of the year in the Netherlands, which is December, you can still drive 40 kilometers on just the sun in a day.
Wonderful, wonderful.
And on a sunny day in the summer, you can drive about a little bit over 300 kilometers on a single charge just from the sun. And on average that's going to be a lot of kilometers and way more than a normal person would drive in the Netherlands.
So we could turn that on its head and say that because it has a battery in it, you also have the option of it working at night for a certain distance.
Yeah, absolutely. There's a battery in it, and that makes it drive about 600 kilometers at night. So you can just drive through the night to your destination if you want to, and then during daytime you can recharge the battery from the solar cells again.
Well, it's an overworn term, but I think we are looking at the future here, and clearly this sort of product is not stopping at this. There's a whole engineering roadmap for this, I guess. I mean, we've heard some delegates talk about how some of the really flat solar racers could be transparent underneath and use the infrared of the road with the same cells, because the cells, some of them, can absorb infrared and make it into electricity, and even ultraviolet. In your case, are you looking at any, I suppose it's a secret, I suppose I'm being unfair, but I mean, looking around, the mind buzzes, energy harvesting shock absorbers, better aerodynamics, do you feel there's more further to go?
Yeah, absolutely. I mean, we're working with the university, Eindhoven University of Technology, but also with all the sponsors. We're trying to develop new technologies which we can use in this car, but also in other areas of the technology. And that's what makes this project so great, that we can actually work with other companies and the university and the government to come up with new solutions, which we can use in all kinds of fields.
So, I mean, for example, if this was not so much a solar racer, but used in practical use and developed for practical use, it would obviously have an immediate novelty peak with people who want it because it's fun, it's interesting, whatever the price, and then it might be sold to people who would use it more seriously and were willing to pay to be green. We're interested that all sorts of other things in this hall, indeed, that have been discussed, like the IFEVS pizza van, which erects a telescopic wind turbine, and it's a very advanced one. It's 4 turbines that are annular, so they're more efficient, and so they get 400 watts from that in windy places like, indeed, parts of the Netherlands, my country, England. Do you think that there might be multi-mode harvesting coming in?
Well, for a solar car, it's always difficult because you also have the regulations that you can't be really wide.
No.
But who knows? You can, if the car standing still, of course, you could do all kinds of stuff.
It has to be when it's stationary, obviously, for wind power. The physics wouldn't make sense. But other things being worked on, we've heard in the lectures about triboelectric tyres, which may or may not succeed, but might give us another few hundred watts. So I think it's very exciting. Can we come round to the front? I'd like to ask a question here. We want to ask a question here about the front. I think I understand that is not a quirky design just to make it unusual. There's a serious reason, isn't there?
Of course, it looks very awesome just to have this really nice tunnel in front of it. But actually the reason is that if we have a tunnel over here, we can reduce the frontal area of the car, and in that way the air resistance reduces, and we can actually drive a few more kilometers on a single charge, simply because the air resistance is less. And in that way we have done a lot of other tricks, as you may call it. As you can see, like the roof itself sticks out a little bit, and that way we can just put one extra row of solar cells on the roof, which again gives it a little bit more energy we can use.
Every little part. And I noticed that the parent company of the Eindhoven, of the people in Delft, has been creating other businesses, like using some of the knowledge for a self-powered trailer, which is not solar at all, but also using some of the knowledge of the aerodynamics or the skills to make a vehicle for the disabled. Is the Technical University of Eindhoven interested in creating spin-off companies using some of what you do?
Well, absolutely. I mean, we have a few spin-off companies that are actually from the solar teams. One of them is a company, Lightyear, which is actually going to investigate if it's possible to bring solar cars to actually the real world, and if it's possible to make them actually more of them, so actually people can buy them. And they're looking into that, and we hope, of course, that we will see more of these kind of spin-offs from the solar team.
I think that's very fundamental. I think we've heard of Formula One talking about how previously they have been not just toys for boys, they've been giving the world the disc brake on all our cars and giving the world kinetic energy recovery systems where the electric motor goes backwards on our electric cars, and all sorts of lightweighting, the first to use carbon fibre, and then we see it in the BMW i3. And so Formula One with the bang bang stuff has been giving us technology that has been enormously beneficial. It's not just a business that in my country, Britain, is about $12 billion. It spins off much more business, but in our opinion in ID TechX, this is the new Formula One. These are the sort of products that are going to give us all manner of spin-off technologies that we can use on other vehicles, and then on the real McCoy, the energy independent cars, buses, planes, boats, and all the rest. Do you you are personally at the Technical University, are you?
Yes, yes, we all are.
So do you get involved at all, like the Delft people, in things like boats or anything? Or?
Well, not in boats yet. The Technical University of Eindhoven is actually specializing in especially the automotive. So we got a lot of other teams who are also focusing on other kinds of transportation. There's an electric bike which drove around the world. There's another car which is made of biocomposites, which is really clean to manufacture. Actually, they're focusing on the manufacturing part. And then of course there's a race team as well. All electric vehicles, and in that way we are really focusing on the transportation, because that's going to be a big thing in the upcoming years. People want to travel more and more, and are traveling more and more, but at the same time you want to be more environmental friendly.
No, that's wonderful, and we've been aware of a few other enabling technologies being worked on at your university. Some time ago there was work reported on not just regenerative shock absorbers creating electricity, but actually a total regenerative suspension. Are you aware of whether that work is continuing at the university?
Yeah, absolutely. We got a whole group actually we're focusing on that, on linear motors and also in suspensions, and to see not only to improve driver comfort, but also in generating more electricity for which you can use to actually drive.
Right, so that's a bit like Levant Power, the spin-off of MIT, which has all along said it's one thing to just have shock absorbers, which on a bus or a train could give you 10 kilowatts, but if you use that electricity to create active suspension and you get a much better ride, people will buy new cars, if only because they can get over the speed bumps without you even knowing it. Indeed you save a lot of energy if the vehicle isn't lurching about all over the place. So it's quite significant that some people like Tufts University and the rest seem to be working just on energy harvesting shock absorbers, but your university and Levant Power in America are working on something far more ambitious, which is a total suspension, which gives all multiple benefits that you don't get just from a shock absorber producing some electricity. Do you have an interest at all in structural electronics? I mean, another dream would be like the bodywork of a car is being experimentally made into supercapacitor. So whereas at the moment no way you'd use a supercapacitor, it'd be far too big, far too heavy, you might perhaps move towards that. This is very speculative. If you did what Vanderbilt University is doing, Imperial College London with Volvo, and the Technical University of Queensland in Australia, with structural electronics, where maybe even the battery, although the trouble is even solid state batteries swell and shrink, so they're going to be in bodywork anytime soon, but do you think there's potential for hiding away your battery more cleverly, shall we put it that way?
Well, of course. I mean, it's really a developing market, and a lot of new technologies are arising here. And one of the things is, if people are accepting it more and it looks better, it gets easier to the market. So if we can reduce the size and for example, also solar cells, if we can put them somewhere else, people don't see it anymore. It's going to be easier to adopt the technology, actually.
Yeah.
And the same goes for making the batteries smaller, more distributed.
Yes.
And that always helps to make the technology come to the market faster.
Perhaps you need to split in two in a way, because the actual race rules, when you're in racing, you're inhibited from doing many things. You couldn't, even if you could afford it, put gallium arsenide everywhere. The old rules used to restrict how much, so trying to have a level playing field, and so on. And if you're unusually small, they'll make you carry weights like a jockey so you don't get the advantage of being very small and light, and so on. But in a different world, the real world of having things that could be sold, presumably you could look at things like solar glass. We've just done a report on solar glass. So that could be making electricity, presumably, although the race rules might not let you. Every little bit helps, as they say. Does that make sense or not?
Well, absolutely. I mean, the efficiency will always be less than just a normal solar cell, of course. But if we can get the price down far enough, it's going to be interesting anyway. So it's all a thing of how much does it cost, and if you can reduce the cost, it's going to be interesting.
Yes, absolutely. It's an interesting thing too that we think we're not alone in this, that we're just listening to what people say who run cities and so on all over the world. They're increasingly deliberately making it more difficult for cars. I mean, in London, a typical city, it can have over 10% of the space is car parking, which is ludicrous, and that cars are used only 3% of the time, and that causes the enormous car parking space, but it also causes traffic jams when they are used. And so there's a move, and there's a machine elsewhere here that's more a sort of squared off, very glassy product that's called an e-taxi, but it's thought that within towns, whether they're autonomous or not, they will be banning private cars. And then as you get to them to and from places, you will a thing like an autonomous taxi is wonderful, because you young people, you don't want to do that, you want to do this non-stop.
Absolutely.
Non-stop. And so in that world, you want to sit in your taxi facing each other maybe, and you probably don't want to share it with anyone else, but there's an issue there. But those sort of products are actually somewhat reminiscent of this, because they're fairly squared off. They take several people, and they could even alternate between being a taxi and a bus. It's all being reinvented, isn't it? So in my opinion, a lot of this is not just relevant to a private car, it's relevant to a taxi that merges with a car, that merges with a bus, and is people can get on it much faster because of different advances in geometry. So you say you do look at other things. You have in your organisation an automotive objective. You do look at taxis and buses and things?
Well, absolutely. I mean, you see a transformation in transportation, actually.
Yes.
I mean, the self-driving car is going to be there, and
Yes.
this is going to not only make the car look different, and
Yes.
it's also going to be, I don't know if everyone's going to own a car anymore. Probably not. You're going to
Yes.
share it with other people, and this is
Yes.
just because of the new technology that we are
Yes.
seeing. And this is also something we are working on. I mean, this car is not autonomous yet, but we are developing together with one of our sponsors, NXP, the self-driving technology, car-to-car communication, car-to-infrastructure communication.
Yes.
And that way you can see, okay, this traffic light is going to turn red in a few seconds, so you better just already start braking, because it doesn't make any sense to just drive there on full speed. And this is already where we're working on, and we'll see this progress over the next few years. And that way, the interior of the car is also going to change, and this gives way more freedom into how you're actually going to make this car, and that's going to be really interesting. And if people can just work in the car, why not just be in a traffic jam, because that doesn't really matter anymore.
Yes.
And you can generate electricity with a solar car over
Yes.
there, because you're in a traffic jam. And if you can work there, no one actually cares they're in it. So this is going to
I think
completely
that's
reshape
wonderful.
it.
I think just as we see some huge car companies, automotive companies, are in denial, really. They do some nominal electric vehicles, maybe the odd hybrid, maybe the odd pure electric one, but they're really in denial, and they're heading for a brick wall. They're in serious trouble when the tipping points come. In our opinion also, a lot of universities, they have the automotive activity as part of mechanical engineering. I think that is not the case with you, is it? Some universities now have said no, properly it's part of electrical engineering.
Well, of course,
electronics.
it's a multidisciplinary part, and but especially our software and our electronic departments are seeing. You see major developments over there, and of course the car is going to get lighter, which is part of mechanical engineering. But at the moment, the most innovative part of the car are actually the software behind it, the sensors behind it, the batteries, the motors. Is getting more and more efficient.
Well, indeed, if the bodywork ever did become electrical, and indeed that bit just did, it's electrical engineering, it's not mechanical engineering in a sense. You mean, it's semantics, you could argue about it, but yes, we're moving in that direction, aren't we? So is there this material, are we allowed to know what that is, that fiberglass, or is it
It's all carbon fiber. It's a whole monocoque, completely carbon fiber.
All carbon fiber.
Yeah.
So that's BMW with the i3 and so on is not alone, and this is not glass. It's polycarbonate, is it?
It's polycarbonate. Yes.
Okay, and you've obviously got LEDs, so you don't waste an enormous amount of power.
Yeah,
and,
it's all the most efficiency you can get. So.
Yes. Oh, that's very interesting, and I don't want your secrets, but forward here, we do have we've been studying lightweighting. We have a report on it, and we've got talks on it. And it's quite interesting, a bit like electric motors. No one agrees, you know, even in the same vehicle you can have asynchronous or synchronous or switch reluctance, and they all have their favourites, and it doesn't settle down on one type. But first of all, what type of motor do you have? Is it permanent magnet?
It's a permanent magnet.
Yeah.
It's a brushless DC machine.
Yeah.
It's actually integrated into the wheel, so we don't have any transmission, which would add weight, but also moving parts, which is unreliable again.
So we should properly call that an in-wheel motor or a near-wheel motor?
It's really an in-wheel motor. It's the motor, and around the motor there's the tire.
Right, because they've tended to feel that they're going to go commercial in a big way, the in-wheel motor people. It's always next year. It will come, but I think it's going to be in hundreds of vehicles, at least at the beginning of next year, but you're ahead of them. So that's a futuristic thing too. And I suppose if you did a commercial version, not for a racing version, that would give you the option of vectored steering and vectored traction.
Absolutely. At this moment we just have an electronic differential because we only use two motors, so in the front wheels.
Right.
But you could also put them in the back.
Right.
So you got actually four-wheel drive,
right,
which has a lot of advantages. And then you can use factor control to improve the ride even more.
So we've seen a trend with all forms of hybrid powertrain and pure electric powertrain to go from one motor to two, sometimes three, sometimes four, and you're within that world, indeed. And
we absolutely believe it goes to four-wheel drive because that's just the most efficient.
And the wheels have to be a compromise, I guess, because staying alive and getting there fast.
Yeah, that's true. At the moment, they are just the tires on it are pretty small, very thin, but they're just normal tires. You also see on motorcycles, and they have a really low resistance. But you can drive on it for more than 1,000 kilometers on one, on one tire.
Now, Bridgestone is a tire company, isn't it?
Yeah, but they're a sponsor of the World Solar Challenge, so they're not our sponsor.
No,
we also don't use
that,
any Bridgestone tires. So.
But Bridgestone doesn't get involved in state-of-the-art tires for solar cars?
They are getting involved into it, but we still have, we made another choice for
I realise they're not your sponsor, they're independent for the race, but yes, we've heard about Michelin getting involved and so on, so that's really interesting. Well, thank you for withstanding a marathon interrogation. It's really interesting. I could go on all day and all night. I think I'd have one message, I think, for anyone who's watching this. If you think it's all happening in China or America or Japan, watch out. The Europeans are ahead of you in a very large number of ways. The Europeans are doing very well indeed, and they're showing the way. So they haven't got all the answers, but here in Europe, a great deal is happening very fast. Thank you very much. Wonderful.
Yeah,
wonderful.
thank you.
Thank you.